Hey everybody, Trey here. Welcome back to another video. This is going to be our initial video on the potential severe weather outbreak that is on tap for parts of the central and southern U.S. Monday and Tuesday of this coming week, April 15th and 16th. We've been talking about this for a few days now. It's been pretty rampant over social media how intense this setup is looking. Today, we're going to take a look at the pros and cons of this setup as far as severe weather goes. There are a few drawbacks that we need to talk about that could be flies in the ointment for this upcoming setup, but overall, it is looking like a pretty intense couple of days, anywhere from the southern plains, Texas, Oklahoma, eastward into the Midwest, Mid-South, and potentially the Southeast. And we could see some severe weather on Wednesday as well, but we're just not quite at the confidence level we need to outline any severe weather risk areas for Wednesday. So we're going to focus on Monday, Tuesday, in this video. This is what the SPC has right now for Monday, April 15th. Enhanced risk level 3 out of 5 there for parts of northwest Texas into the western half of Oklahoma, including the OKC metro, up into southern Kansas, including places like Wichita. So broad area of greatest severe threat there from southern Kansas into northwest Texas. And we have a broad slight risk surrounding that up from Nebraska and Iowa southward into central Texas. So a broad area of severe threat is in play on Monday, and that some of that could be significant severe weather. We don't have the hazards yet, of course. It's day 3, so we don't have the tornado, wind, hail probabilities, but we do have the severe weather probabilities, and we have had a 30% hatched area outlined here within that enhanced risk, as well as a hatched area all the way up for much of this 15% slight risk area from southern Nebraska down into central Texas. So a broad area where we could see some significant severe hazards, including possibly some significant damaging winds, possibly some very large hail, and a few tornadoes. So we'll go through the setup for Monday before going into Tuesday, where we have a broad area of severe threat that is expected to take place. Again, up from the Midwest, southern Wisconsin, Iowa, Illinois, Indiana, southwestward into parts of Arkansas, eastern Oklahoma, and the Arklatex there. So could see a widespread area, see severe weather on Tuesday. What happens on Monday is going to be very critical for what happens on Tuesday, so we're not quite sure about any higher areas of potential there within this broader area of risk. Those will probably come forth over the next couple of days as we get a little bit more confidence in how Monday is going to go. But overall, we could see a pretty potent day on Tuesday as well. So a couple of days where we could see some significant severe weather across a broad swath of the U.S. In this video here, we're going to take a quick look at the current state of the atmosphere, what's going on as we record this video, and then we'll go into our typical comparison of the models. We'll go through our 3 models, NAM, GFS, and Euro, take a look at the different possible solutions that those models are showing, and come up with some possible outcomes for this setup. So without further ado, let's go ahead and get started. Let's first take a look at our upper air maps on the SPC mesoanalysis page. This is our 500 millibar map. And the trough we want to take note of is this one here, off the west coast of California this morning as I'm recording this. You can't see the full thing in this image, but you can tell that it is starting to really amplify a little bit. Looks like a bit of a closed circulation here at 500 millibars. That is going to continue to dig down into the desert southwest and eventually eject into the southern plains by Monday afternoon to evening. And that'll be our main forcing mechanism on the synoptic scale for our severe weather threat on Monday. And then the trough progression that'll continue into Tuesday. We'll show you some model data here in just a second how that is expected to take place, but we'll have plenty of forcing for severe storms on both Monday, especially Monday evening, going in through the day on Tuesday. A little bit of ridging over the plains right now. We don't have any preceding weather systems coming through to help sweep that moisture, and that is what is going to be a key point in this setup. We're going to have multiple days of moisture return in this setup. We can take a look at our surface dew points at present, and you can see what we're dealing with here. Last couple of days, it's been pretty dry across the southern plains, but that has started to change as flow has flipped out of the south a little bit, starting to allow this moisture to inch its way back to the north. After our previous system, that big event a few days ago, we had that moisture swept into the Gulf pretty significantly, but we haven't had any preceding weather systems to continue that extrusion of moisture, if you will, out into the Gulf. We've had the winds again flip around to southerly, and that is going to continue to take place as the trough finally starts to make its way across the higher terrain of the Rockies out west, and we should see surface low development somewhere here in the eastern Colorado, western Kansas vicinity sometime on Monday, and that will really allow those winds to strengthen out of the south and really pump that moisture northward into places as far north as Nebraska, Iowa, Illinois, southward for Monday and Tuesday. But for now, we have a nice plume of 60s dew points here, sitting really just across the southeast and south central Texas vicinity. You can see the 60s dew points here, basically up to this station right there. Southeast of Abilene. Not a broad plume at this point of 60s dew points. We still, again, haven't had that real strong southerly flow start to take shape, but we have had the winds flip out of the south or southeast to at least start pulling that moisture up to the north, and that should allow for several days here, Saturday, Sunday, into Monday, several days of moisture advection into the region, giving us a nice juicy low-level air mass over a broad area to support a broad region of severe weather. Now, how about the quality of that moisture? SPC in their outlook, in the day 3 outlook this morning, did note some concerns with the quality of this moisture. So let's take a look at a sounding here. This is the Corpus Christi sounding from this morning. You can see at the surface 69 over 66, so we're well within our deeper moisture plume here. But here's the problem. We see quite a bit of dry air just above the surface, not a deep moist layer at all. And that could be somewhat problematic as we go into Monday. Now, I do think we're going to modify this profile somewhat. We will deepen this moisture a little bit, but how much we deepen that moisture is in question, and it doesn't look like we will deepen that moisture all that much. So we may see a fairly shallow, low-level moist layer beneath a pretty stout capping inversion aloft, which may mean some issues for daytime storm development, really until the trough moves in on Monday. We talked about the timing issues a little bit in our post on the page here yesterday. We'll go into that here in just a second. But we have seen a little bit of a slowdown in the trough over the last couple of model runs, and that could allow for that cap to hang around for much of the day and preclude any daytime storm development. But we'll talk about that here a little bit more in just a second. How about another sounding here at Brownsville? A little bit deeper moist layer, a little bit more evident moist layer at least, beneath a pretty broad plume of dry air aloft. So definitely shallow moisture where our best low-level moisture is sitting right now. And that could be a little bit of an issue as far as a little bit stronger cap that may be in place across the central and southern plains for the Monday setup. How about we go back to the 0Z sounding last night? How about at El Paso? And you can see where our elevated mix layer is coming from. Very deep layer of well-mixed air last night at El Paso. Steep lapse rates, dry, well-mixed air there in the low to mid-levels at El Paso. And that has since translated off to the east. We can take the sounding here at Oklahoma City, and you see a nice little plume last night here of steep mid-level lapse rates there, drier air aloft. That is our elevated mix layer. So we will have a pretty nice elevated mix layer in play here. And again, that could add to the cap, but also will keep the atmosphere free and clear of convection going into the day on Monday to allow that instability to build for when storms eventually do fire. So all in all, the hallmarks of a severe weather event are here. Big trough going to be coming in from the west, elevated mix layer atop a somewhat of a moist layer, but that moist layer is a little bit in question as far as its quality as we go into the Monday-Tuesday time frame. All right, let's dive into some model data now. We're going to look at our 3 main models, as we always do in these more medium-range outlook videos. We're going to take a look at the 6Z NAM, the 6Z GFS, and the 0Z Euro from last night. So 3 different models to take a look at, and we'll come up with some solutions that they're showing, see the differences and similarities among the model solutions to come up with some outcomes, some potential outcomes for Monday and Tuesday. We'll start out at 500 millibars on the 6Z NAM. Here is our trough in question here off the western California coast. That is going to continue to dig down into the desert southwest over the next couple of days, maintain its identity as a closed trough there, closed low at 500 millibars, and finally eject into the south central plains by Monday afternoon to early evening. Now, the timing of this trough ejection has changed a little bit over the last few model runs, and to show you that, I'll show you the GFS ensembles over the last several runs dating back to the April 6th evening run that day. So this is basically going back a week from the current recording of this video to show you how the different model runs have changed with respect to the trough ejection. So these maps are valid at Tuesday 0Z, so Monday at 7 p.m. Central Daylight Time. So watch how the trough has progressed over the last several GEFS model runs. You can see here early on it was well over the dryline region, or the main region of interest over the Kansas, Oklahoma, Texas area. The exit region of the trough had well impinged upon the central Kansas, central Oklahoma, North Texas vicinity. But watch what has happened over the last several runs. You can see that the axis of the trough and the overall exit region has shifted well back to the west. This is our most recent run from yesterday evening, much different than what it was a few days ago. The axis of the trough well back in here now, with our main plume of stronger flow just starting to impinge upon the area of interest here from the Texas Panhandle, western Oklahoma, southwest Kansas, into northwest Texas. So we have definitely seen a slowing of the trough over the last several model runs, and that has some implications on the overall timing of the severe threat. This could do a couple of things. Number one, it could allow for a little bit weaker forcing during the daytime, and that may allow for a more discrete storm mode, although the capping, which we'll look at here in just a second on the model data, the capping may remain strong for much of the day until that main forcing really starts to impinge upon the region after 0Z, after 7 p.m. Central Daylight Time on Monday. And going along with that, it could also allow for a little bit of a delay in the onset of the greatest convective coverage and intensity until after sunset. So this may be a little bit of a problematic thing for storm chasers, and especially and also for residents here in these areas, because this threat may be mostly a nocturnal threat, which as we know is very, very dangerous, very hard to spot tornadoes at night. And so that could be a definite dangerous aspect of this potential outbreak. So this is valid at 7 p.m. on Monday. Let's take a look at the GFS now, see how it progresses the trough itself. So here we go into Sunday and Monday. That trough, very similar progression to what it was showing on the NAM. So here we are at 0Z Tuesday, so 7 p.m. Monday. Let's compare it to the NAM. Fairly similar solution here, not much of a difference in the overall depiction of the trough. So these two models are definitely on board with a similar solution. Trough takes on a little bit more of a negative tilt with time, and the exit region of the trough starting to impinge upon southwest Kansas, the eastern Texas Panhandle, western Oklahoma, sometime around 0Z, 7 p.m. on Monday. Same thing you see here on the GFS, maybe a little bit of a difference in trough geometry, maybe a slightly more positively tilted trough here if we were to draw through the axis itself. But overall, the idea is pretty much the same, neutrally to slightly negatively tilted trough, moving into the southern and central plains. Right around 0Z Mondays, when that stronger flow aloft in the exit region of the trough starts to impinge upon the area of interest there in the southern plains. How about the European model? Let's see how the Euro handles this trough evolution. Very similar trough, closed low, moving across the Great Basin into the southern plains, and this is what the Euro is showing at 0Z, so 7 p.m. on Monday. Compared to the GFS, and the NAM looks pretty similar, just some slight differences in the trough progression. European model might be the least progressive of the three. The axis is all the way back in here, basically along the Arizona-New Mexico border up into the Four Corners region. If we were to draw it in here on the GFS, maybe a little bit farther ahead, and then on the NAM actually might be the most progressive here, and the most potent shape here, and that would allow for possibly some daytime development here before the sun goes down on Monday. So a little bit of a timing difference still among the models, with the European solution the slowest of the three solutions. That would definitely allow for the convective onset to become pretty much delayed until probably sunset or after, when that flow really starts to impinge upon the area. You see here we go to 6Z. By 6Z, just after midnight, the exit region of the trough, the main stronger flow associated with this trough, well within this region, and so that would allow for convective coverage and intensity to blossom. Same thing here with the GFS. We finally get that little wave to move into the region. Same thing there on the GFS. And the NAM certainly would favor a solution of daytime development. Just in the hour or two before sunset, we would see the onset of convective development. So that would be the favored solution from a storm chasing perspective, of course. And then as we go into the evening hours, that is going to, the forcing will increase drastically. We could see a degradation of a potential discrete supercell mode into more of a clustered linear mode as we go on into the early morning hours on Tuesday. Let's back up these models. Let's take a look at the progression of the surface pattern here. I'll back these up on all the models so we can look at how the surface low is expected to progress on each of these models going into Monday. So here we are on the 12Z NAM, not much to speak of here. Surface high pressure out centered over the Gulf Coast states in the northern Gulf of Mexico. That has allowed for that flow on the west side of that high pressure to be a little bit more out of the southeast, and that has slowly started that moisture return process here into the southern plains. Surface low well out here up off into eastern Canada. Not much else to speak of here across the western portion of the country, but that will change as we go into the day on Monday. So here we go. Little bit of surface low development tomorrow with a little bit of a passing system here. There is a slight risk out for parts of Ohio, Pennsylvania tomorrow as we get a little bit of this disturbance to come through tomorrow morning and afternoon. And then behind it, we'll start to see broad cyclogenesis sometime late Sunday to early Monday, and you see very strong surface low development there across northeast Colorado by 18Z Monday. So 1 p.m. Central Time on Monday, we start to see that surface low really develop across northeast Colorado, and that flow in the warm sector out ahead will really strengthen and back to southerly or southeasterly to really pump that moisture northward into Nebraska, Kansas, Oklahoma, and Texas. This is at 4 p.m. and 0Z, so 7 p.m. Very tight surface low, a little bit farther north than is typical for a lot of southern plains severe weather outbreaks. Usually we like to see that low somewhere in southeast Colorado to southwest Kansas to really provide that extra oomph for severe weather out in the southern plains area. But we should have a broad enough warm sector, plenty of stronger low-level flow within this region to support a severe weather threat ahead of the dry line. Surface, we could have severe weather also up to the surface low region up here into Nebraska and Kansas. So a broad area of severe weather certainly on the table for Monday, given a broad warm sector in play. So this is at 0Z, 7 p.m. on Monday. Let's take a look at the GFS. GFS, very similar look to it here as we start off. Going into Monday, we start to see tight surface cyclogenesis there, pretty much the same spot as the NAM by 18Z, 1 p.m. on Monday. That's 4 p.m., 7 p.m. on Monday. Very similar look to what the NAM was showing, maybe just ever so slightly more progressive with the surface low there up in western Nebraska, but overall a very similar look to what the NAM was showing. You can already start to see that NAM cool bias here in the warm sector, very cool temperatures out here. Again, we know the NAM has a classic bias to underdo surface temperatures. You can see on the GFS a little bit more dark orange and reds here out ahead of the surface low, indicating warmer surface air there. So the NAM certainly likely going to have some bias there. Once we pull some soundings, you'll see probably that will allow the cap to hang on a little bit longer if we have cooler surface temperatures. Here with the GFS solution, probably not as much. So something to keep in mind as we go forward. Here is the European model, and much of the same look as we go into Monday. Then we get cyclogenesis there, 18Z Monday, 21Z, 0Z. Very similar look to what we were seeing on the other models. The European model is a little bit farther south. As we said, the European model was the most delayed, just ever so slightly, but still it was the most delayed of the three models with the ejection of the upper trough. So the surface low a little bit farther south, a little bit weaker perhaps than what the other two models were showing. GFS and NAM very tightly wound surface low. Still here, same thing on the European model, but it is maybe a little bit more strung out and a little bit farther south oriented than the other two models. But overall, the idea is the same: broad surface low, or very tight surface low with a broad warm sector ahead of it. Speaking of the warm sector, let's go ahead and take a look at the moisture progression going into Monday. So I'll go back to our dew points here, and I will zoom into our southern plains sector so we can get a better look at the overall progression of the dew points. So here we are. I'll fast forward to just right about our current time. This is 12Z this morning. A little bit of a plume of 60s dew points here in south central Texas off the Texas coast. That will continue to stream northward slowly through the day today. Not much of a northward advance of those 60s dew points until we get into Sunday. We'll start to see that surface flow really start to take shape out of the south. That will start pulling those 60s dew points northward to north of the Red River here, at least on the NAM, by Sunday morning. Broad area of 60s dew points developing by Sunday evening. And then as we go into Monday, we get a very tight dry line to develop ahead of the surface low. Again, the surface low up here into the Central Plains. Just for a refresher here, surface low, this is at 7 p.m. Located somewhere here in the Scottsbluff vicinity. So surface low out in here, warm front likely up somewhere in the South Dakota vicinity, I would suspect. Yeah, it looks like up here just north of the Nebraska-South Dakota border. So our warm front somewhere in this vicinity here, and a very tight-looking dry line out ahead of the surface low down into Kansas. A little bit of a dry line bulge that appears to have developed along the Kansas-Oklahoma border. That could be a favored area for storm initiation in this environment, perhaps in the daytime if we are able to get daytime development. As we know, as we talked about before, the dryline bulge is a favored area for storm development because it has a little bit stronger convergence along it. We'll have strong convergence along the dryline, the entire length of the dryline, but this dryline bulge may be an area where it is locally enhanced, and also low-level shear tends to be a little bit more enhanced along these dryline bulges. So we'll see if the other models have this as well, as that could be a favored area for storm initiation in this environment. Going down to the south here, southern plains sector, you see the dryline extends well down into West Texas, so we could see some storm development down as far as the West Texas area on Monday evening. So very nice looking dry line there. I'll back it out to the contiguous U.S. sector, see what the GFS is showing as well. So same progression of the moisture, slow to get those 60s northward until about Sunday morning to early afternoon. We get those 60s up to the Red River region by about 10 a.m. on Sunday, and that continues off to the north in earnest on Sunday into Monday morning. Again, a very tight dry line does develop ahead of the surface low. I'll zoom in here a little bit. And first, we'll take a look at the comparison. The NAM definitely farther west with the moisture, and that is a pretty typical NAM solution. Does tend to be a little bit farther west with the moisture, so our dry line looks to be right in there. Southwest Nebraska, western Kansas into the eastern Texas panhandle. On the NAM, GFS much farther west. Not sure I truly believe this solution with such a strong surface low back here in western Nebraska. I would suspect you'd get better moisture up here into places like southwest Nebraska, western Kansas. So definitely think the GFS is a little bit too progressive with the setup of the dry line. Let's analyze the dry line a little bit more closely. We perhaps do see a bit of a bulging in the dry line here across Kansas. Not quite as high resolution of a model as the NAM, so we really can't really identify those tight bulges. But we do have a little bit of a bulging outward of the dry line there into Kansas with a broad area of 60s dew points in ahead of it. Down to the south, we'll have, again, a lot of real estate for severe storms here with this tight dry line. And so we should see storm development along this dry line at some point. Just depends on when that forcing arrives and when that cap is going to fully erode. We don't have moisture on the COD page for the Euro, so we'll take a look at the pivotal weather page for the European model. And I'll just go out in time here so we can save a little bit of time for this video. So this is going to be Monday at 7 p.m. So here is the look of the European model on the from the 0Z run. So surface low out in there, dry line out ahead of it. Definitely not quite as favorable of a look with the dry line, not quite as widespread. 60s dew points up farther to the north here. Just kind of a little bit of an amorphous dry line, if you will, but still would favor severe weather development along it. Not so much of a dry line bulge here as we were seeing on the other models. I'll go back to the NAM for you to compare. NAM is a much more potent solution. NAM is definitely on the higher end of the guidance here, so keep that in mind. It does tend to be, so we do see the NAM often display higher end solutions, but certainly this would be one of those times. So we'll have to keep that in mind. GFS very similar, but a little bit more progressive, and then the European model doesn't look all that favorable here. It's definitely backed off from some of its runs a few days ago. But still would favor the storms along the dry line. That dry line really does tighten up going into the nighttime hours on Tuesday. This is Tuesday morning, 12Z. That cold front / dry line will really start to push off to the east, and that will be our focus for severe weather on Tuesday. So let's take some soundings here. We'll take some soundings all the way across the region. So first we'll take it one right ahead of this dry line bulge. That would be if this solution were to come to fruition, this would be my favorite area for a storm chase target. So this is at 0Z, and that is a pretty interesting look here, especially kinematically. It's huge photographs, over 300 meters square per second squared effective helicity, 0 to 1 kilometer SRH, almost up to 600 meters squared per second squared. So large looping photographs, strongly favorable photographs for significant severe weather. And that has to do with the strengthening of the low-level jet. We'll put up our 850 millibar winds here. Very strong low-level flow developing through the day as that surface low tightens, and then especially into the nocturnal hours, which is what we typically see with the low-level jet, a nocturnal ramp up in the low-level jet, but a very broad area of strong low-level flow helping to really increase those low-level winds. So kinematics looking pretty darn good with the setup. A little bit of a weakness here in the photograph. A little bit of an M shape in the photograph, but shouldn't be too much of an issue there, given very strong low-level shear and the fact that little bit of a backing area is farther up in the atmosphere rather than down here in the low levels, which is when I really start to see it be a problem in these setups. The issue here on the NAM is definitely thermodynamically. We see very limited instability here, and I think I would take this with a grain of salt. 70 degrees here at the surface at 7 p.m. on Monday. I just want to take, just for giggles here, let's see, this is going to be the Dodge City office, I believe. Yes, we'll take one here. We'll take the Dodge, NWS Dodge City, and we'll just take, I'd like to do this here for these types of setups where the NAM is just looking a little bit out to lunch. So I'll take a sounding here just out ahead, well to the northeast of Dodge City, ahead of the dry line. And we'll see here, the high on Monday is expected to be 84 degrees. So we'll see Monday night, low around 56. So we would expect that probably to be somewhere in the upper 70s to maybe near 80 as we start to see the onset of cooling from near sunset. So if we expect this to be about 10 degrees shy of what it's actually going to be, this is going to be a very different thermodynamic look from what it actually will be on Monday. So obviously the NAM showing its cool bias. But one thing to note is the depth of the moisture. We see a very shallow moist layer here, and that is one thing we just talked about a little bit ago. We took our observed soundings from the South Texas area where our moisture is located, and so that is not expected to change a whole lot, that lack of a real deep moist layer beneath this pretty stout capping inversion. Elevated mixed layer will be pumping its way in on the mid-level southwesterly flow from the higher terrain out west, and so we will have a very stout capping inversion in place. And I'll take a sounding here on the GFS in the same spot just so we can see how the thermodynamics are progressing, are looking in both kind of areas. So this will be a little bit farther to the east. Remember, the GFS was a little bit more progressive than the other models, but we'll take one here just north of Wichita, kind of in the same area, and you see a much different profile here. About almost 2,000 joules per kilogram mixed layer CAPE, and the GFS, something to note that the GFS often is on the lower end for instability in these setups. So I definitely think the NAM is out to lunch with the thermos here for this setup. GFS showing much more favorable thermodynamic profiles, 77 over 64. That's a lot more, looking a lot more accurate. But you see the low-level profiles here, not all that textbook looking as far as the moisture goes. We want to see that kind of loaded gun look. A little bit of capping inversion remaining here, but if that forcing can come in, when that forcing comes in, that will erode pretty quickly. And if we get the temperatures up into the 80s here by late afternoon, I think we should still see the potential for daytime storm development along the dry line, especially if we can get any bulges to develop like this as shown on the NAM. So we'll have to watch that and see if that comes to fruition, but I just think the NAM is completely out to lunch here with the thermo profiles. GFS obviously a little bit lower resolution, so we can't really identify the moist layer here and the real thick layers of capping, but overall this is a much more realistic look, I think. Pretty destabilized atmosphere with still a strong kinematics in this environment. A little bit of a wonkiness there in the photographs still, so we'll have to keep that in mind. That could allow for precipitation to get thrown out ahead of any tornado, so they could make viewing a little bit more difficult. But we do have quite a bit of venting here above that layer, which could also help vent the precipitation away from the updraft and the tornadic area, any tornadic mesocyclone areas in these storms, to allow for better viewing. So kind of a give and take there with these photographs, but still low-level shear looks favorable, strongly strengthening and veering winds with height in the low levels, almost 300 meters square per second squared effective storm relative helicity there, with large clockwise turning photographs. So kinematics not going to be an issue so much with this setup, but thermodynamics are going to have to be watched. And I think I would take this NAM and run and throw it out as far as the thermos go. This just does not make any sense at all. We will see destabilization through the day, and this looks a lot more realistic. But definitely going to have to keep that shallow moist layer in mind, as that could be a definite detriment to this setup with a lot of dry air aloft and perhaps some capping hanging around into the evening hours until the forcing comes in. I'll take a sounding here at a 3Z, so this will be 3Z up in Kansas. We'll take one down here into western Oklahoma as well, ahead of the dry line. And so this is 0Z, 3Z here. Definitely a lot better looking, but a lot of dry air aloft. Again, that could be a detriment to the setup. Some dry air entrainment into these storms could allow the updrafts to struggle a little bit, at least initially, until the main forcing comes in. This looks a little bit better. I still think we're too cool here. This is going to be at 10 p.m. So the temperatures will be coming down here. A lot of capping remaining, which could be a detriment. Here we are in western Oklahoma, a little bit better moisture to the south. And this would be definitely a concerning look. Again, this is at 10 p.m. Central Daylight Time on Monday. quite a bit of instability, 2,300 joules per kilogram mixed layer cape, strongly curved hodographs, long hodographs favoring supercells, deep layer shear in excess of 70 knots, with effective storm relative helicity nearing 400 meters square per second square. So this is a very concerning profile for any discrete supercells moving into it. And we've talked about before, if we can get mature supercells to get going before the nocturnal cooling and stabilization occurs, the decoupling of the boundary layer, then we could see a significant tornado threat develop. We've talked about this in events like Greensburg, Kansas from 2007, where you have mature supercells ongoing in a fully surface-based environment, but as that low-level stability moves in, that capping inversion moves in with the onset of cooling after dark, you get an increase in low-level shear, very strong low-level shear. That adds to the buoyancy of the environment and can help overcome that with any mature ongoing supercells. The key is to have mature ongoing supercells in this environment. If we don't have supercells at this point, and we wait until now to initiate supercells, then we may struggle to get surface-based storms, and that will negate some of the tornado threats. So still, this is pretty favorable. Just a little bit of capping remaining. Definitely is doable as far as breaking that cap with strong updrafts. A lot better looking thermodynamics here down to the south in western Oklahoma. So that might be our favorite corridor for severe weather going into the evening hours down here, closer to that dry line in the eastern Texas Panhandle, western Oklahoma. And speaking of storm mode, let's take a look quickly at that. So let's go, and I'll draw in our dry line here. So our dry line looks something like this, basically north-south oriented, and then we'll put on our shear vectors. That looks pretty darn good. Pretty solid angle off the dry line with these shear vectors to allow for a more discrete storm mode. So I do think we will see, especially if the onset of our main forcing is a little bit later than expected as far as the timing goes, we should see a few hour window for discrete supercells before eventually the forcing becomes pretty strong as the trough moves in, and we see a little bit more meridional flow ahead of the dry line and a stronger forcing that should allow for more of a linear clustered mode going toward the midnight hour and after here to Kansas and Oklahoma. But overall, we should see a window for discrete supercells here, I think, especially probably from that 0 to 3, 4, or 4Z time frame, so 7 to 10, 11 p.m. Could be our favorite window for discrete storms, especially down here in southwest Kansas into the eastern Texas Panhandle and western Oklahoma, where our thermodynamics look a little bit better here as relative to farther north, a little bit more dry air, a little bit more capping perhaps in place. So that is why they have highlighted this area of southwest Kansas into western Oklahoma as our favorite area for storm development in this environment. Looking at the GFS real quick here at 3Z, we'll take a sounding ahead of the dry line just to see down here in western Oklahoma, and one here up in Kansas. So here is western Oklahoma, GFS, and see, this is where the GFS is a little bit out to lunch, I think. We'll see continued warm, moist advection into this region, continued destabilization from the lifting and cooling of any capping inversions from the trough. So I don't think this is all that favorable. So this is, again, farther to the north, so it looks like the farther north you go, the thermos definitely downgrade a little bit. Down to the south, a little bit of that nocturnal stabilization here in the low levels, but plenty of instability, 1,600 joules per kilogram mixed layer cape, continued moist boundary layer, strong low level and deep layer shear for supercells. So definitely looking like that corridor that the SPC has outlined here into western Oklahoma is going to be that favorite corridor for a few discrete supercells going closer to sunset and after dark. Again, timing is a little bit in question. We'll have a little bit more knowledge on the actual onset of convective development here over the next several model runs. So definitely an interesting setup for Monday. Let's now go into Tuesday. I'll back it out here to the 500 millibar map. We'll just look at the NAM and GFS here in the interest of time. So here we are at 0Z on the NAM. So that trough continues to eject off to the east. The main forcing moves in overnight, and it starts to take on a very much negative tilt as we go into the day on Tuesday. This is at 18Z on Tuesday, as far out as our NAM goes, but that is a pretty potent looking trough. Definitely a negative tilt to it now, strong flow rounding the base of that trough. So we should have a broad region of severe threat here going into Tuesday, and it's all going to depend on, again, what happens on Monday night into Tuesday morning. If we see the persistence of these storms into Tuesday, then we will see perhaps that be our main round of storms going into Tuesday afternoon. If we see the storms dissipate a little bit going into Tuesday morning and afternoon, then we might see additional development with a little bit stronger destabilization in the environment for Tuesday afternoon. Here is the GFS, 500 millibar progression into Tuesday. takes on that negative tilt. Very compact looking trough here, not one of those highly amplified troughs we often see this time of year. But plenty of region of severe weather development here. This jet streak will be influencing quite a broad region from the Midwest ahead of that in the left and right exit regions of the main trough. And then down here to the south, we'll get a little bit more of a glancing blow down here in the Arklatex region towards southern Missouri, and that could lead to storm development down there. Let's see how our surface pattern progresses. So I'll back it up here once again. So here we are on Monday afternoon. Surface low up here in the western Nebraska Panhandle area. And then that continues to move off to the east as we go into the day on Tuesday. This is at 4 p.m. on Tuesday. Surface low centered here in eastern Nebraska. Cold front draped down to the south. Looks like back in here almost. Then we'll have this potential for ongoing storms into Tuesday afternoon. So we'll have to watch that for sure. But our main area, we do have, it looks like what could be a prefrontal trough type setup here on the GFS, which is always interesting. You see a little bit of a kink here in the isobars down here into southwest Missouri, western Arkansas, and probably down to the south a little bit more. So that could be a focus for storms here on Tuesday afternoon, and then up here along the warm frontal zone into Iowa, Illinois, over toward Indiana. That could be a focus for severe weather as well. Pretty tight surface low now, very strongly wound up, tightly wound surface low, and we have broad moisture ahead of it. I'll back it out here to the CONUS sector, and we do have very broad moisture out ahead of it. It's at 4 p.m. on Tuesday. Broad area of 60 dew points. Better moisture down to the south, of course. 60s and even 70s dew points here in the Arklatex region. Supporting a broad warm sector for severe storms. A lot of real estate for severe storms here. Let's take a couple soundings just to get a basic idea of the environment. Take one down here in the Arklatex as well. And one thing to notice as well, the cold front not moving all that fast to the east. It does continue to move off to the east here with northern extent up into the Midwest. Down here to the south, though, it does seem to stall out a little bit, which could be a little bit more favorable rather than a crashing cold front, which would be a pretty much instant squall line. We do see it stalling out a little bit, depending on the overall shear vectors with respect to that initiating boundary. We could see perhaps a little bit more discrete development down here from the Arklatex northeastward into Arkansas. We'll see if that comes up. In the meantime, let's interrogate some soundings here. So this is up farther to the north, up in that warm frontal zone, Illinois, Indiana region. Definitely some low-level shear present. Fairly unidirectional wind profile, which is not all that detrimental for the Midwest. Often you'll see these unidirectional wind profiles in these setups. But strong deep layer shear for supercells. Limited instability on the GFS. That could be just a GFS thing. But we do have a little bit more limited moisture up here, but I do suspect that we would see a little bit better moisture here. We have moistened pretty nicely from what we were seeing on Monday. Much better, much more moist profile going up into the atmosphere. Down here to the south, a little bit more unidirectional flow in the low levels for probably more of a damaging wind threat down here. We do have strong low-level shear as far as an SRH value goes, nearly 300 meters squared per second squared effective storm relative helicity. So that could foster perhaps a tornado threat, but probably mostly a damaging wind threat with this look. But much more moist low levels, that moist layer extending all the way up to 700 millibars now. Definitely a stark contrast from what we were seeing on Monday. But again, so let's take a look here at our shear vectors with respect to the initiating boundary. If we can get them to pull up here. Not really coming up. We can use storm motion as kind of a proxy. So here's our boundary. We see storm shear vectors somewhat off the boundary here, especially with southern extent. So that could foster maybe more of a discrete environment down to the south there in the Arklatex region northeastward. Up here, a lot of forcing, so we'll probably see a lot of forcing for storms, a lot of ability for storms to fire along that cold front, especially to the north where the cold front's a little bit more progressive. Down to the south, a little bit less forcing, a little bit more of a glancing blow from the trough, and a little bit more stalled out cold front could foster a few more discrete storms down here in the southern portions of the risk area. So that is what we are dealing with for Tuesday. Very complex setup. And then Wednesday, we'll again have to just kind of wait and see what happens on Wednesday. We're not quite sure yet how that's going to play out. We'll have to see what happens on Tuesday to see what happens on Wednesday. But overall, pretty complex setup here going into the next several days to start next week. But that's going to do it for this video. Again, we'll have more updates as we go on and get a little bit more clarity in the overall details of the setup. Definitely some flies in the ointment for Monday, but it is looking like a pretty potent event, especially from sunset onward as that low-level jet really ramps up. Again, I do see a window for discrete supercells, especially here in the enhanced risk area. This is what the SBC has now for their day 3 outlook. Enhanced risk there from northwest Texas and through the western half of Oklahoma, southern Kansas. That looks like our favorite corridor. A little bit better moisture here, a little bit very favorable look for discrete supercells, and once that forcing comes in, we should see a few discrete supercells develop, and they would definitely have a tornado threat if they can become surface-based initially. Again, we talked about that. If they can become surface-based initially, closer to about that 0Z hour, that 7 p.m. hour, near sunset, before that nocturnal stabilization in the low levels occurs. If they can become mature and surface-based, they will have the pretty good chance of continuing well into the evening, even as low-level stabilization occurs. We will have strong low-level warm moist advection as well to offset that, but strong low-level shear should be able to overcome some low-level stabilization for any supercells ongoing in this environment. Farther to the north, thermodynamics drop off considerably, but still a few severe storms expected up there. Nebraska into north central and central Kansas, and then as well down into central Texas, west and central Texas as well. Could see a few severe storms there. But that main threat, again, is going to be in that enhanced risk area, and the threat for significant severe hazards is on the table. Perhaps some large significant hail, significant damaging winds, and a few tornadoes. Strong tornadoes are not off the table, but again, we're going to have to get that surface-based supercell threat to allow that to come to fruition. And then storms will congeal into a line, clusters and more line segments overnight. That threat will continue for damaging winds and maybe a few tornadoes here going over toward the central Oklahoma corridor, Wichita, down toward Oklahoma City. Could be under the gun for that going into Tuesday morning, late Monday night, Tuesday morning, and then our threat on Tuesday. Again, going to depend heavily on what happens on Monday, but a broad area is possible for severe weather from the Midwest down into the Arklatex. A little bit better instability and moisture down here in the Arklatex region. Perhaps a better threat for discrete supercells down here with a stalled cold front, a little bit more glancing blow from the overall jet streak. Up here, a lot of forcing. Could be more of a strongly forced environment for more of a messy mode, but still profiles are favorable for severe weather up there in the Midwest area. So that's going to do it for this video. Thanks for watching, and we'll see you in a couple of days, hopefully with another update as we get some more data to come in.